Hello and welcome back to another session of Getting into Good Oxide. Welcome back, Sydney.
Hi, Sebastian. Glad to be back.
And I hope we all had a wonderful weekend to recreate and have a lot of fresh energy for the next session here with Vergen. Because last time, I think we see that here we implemented this. So this information about the currently set branch or the checked out branch, that's coming from Good Oxide now. And there probably is much more that we can add here because right now it's literally just this single thing. And yeah, I guess that's just where we continue.
Yeah, exactly. On to the next one.
On to the next one in order. So it's in Git. Oh yeah. I want to say maybe there's an opportunity to make this better already before we move on. So a little refactor around. I'd love to say that I saw this, but it's actually Clippy who told us that we can do map or else here. And then it's just taking this one up, putting it here, and then that's it.
Awesome. Even shorter.
Yeah, even shorter. I don't know if it's better to read because now you kind of have to understand that the map, what comes first here, is actually the second function, and the or else is the first.
That is a bit unintuitive, I guess. Not sure.
Yeah, probably makes total sense if you come from, I don't know, from wherever you come, you know, all as a matter of perspective, I guess. But if you saw the other one first, the other version where this was clearly last, right, then of course it seems, it's a bit surprising. But then again, I've written this from the start myself, and if you didn't see the other version, then this feels quite intuitive somehow. I don't know. I can't tell. I'm confused. So now the next one.
Clippy's happy, so that's all good.
Let's call this refactor. Tiny commits. Oh yeah, right. I added a local override here, and now this shows up. I did think I have a global git ignore, but I think it's not picked up maybe, or is it? Let's see. Can I make it? Can this be picked up? Ah, yeah, nice. Okay, I do have a global git ignore. I think it's automatically picked up, and here's where you can put all your editor related things.
I see, okay. But wouldn't it make sense to still put it into the local git ignore?
Like here?
Essentially, yeah, because I mean, not everyone has this. I mean, okay, in this case, me, for example, I don't have this global git ignore, but I would also need this local override essentially. I mean, I don't know what's the best way to do this.
Yeah.
To put it into the repository itself, or?
Yeah, as far as I know, everything that others don't need and that your build system doesn't automatically drop in here, or that is operating system specific, goes into these user specific git-ignore files. And you see here this target, maybe that's even something that should be in the local one, but I don't know. In this case, I don't know. Probably that's something else. But this local cargo configuration, definitely something that's not for everyone. And sometimes I check in a local repository, local cargo config, because it has to set some compiler flags or something, and then, well, then it can be forcefully checked in, and then it's there, and then people see it. So I guess that's it. But that's just me. Maybe there's other arguments to be made, really. For now, I think that's better, because it's just for the people who do this change right now with Git Oxide. All right, now all I wanted to do is call this refactor. Hey, why is this local git ignore changed? I think I accidentally adjusted something in there. Let's just call it refactor. Usually I do thanks Clippy here. And let's just see if we get through with this. Cool. Now, what's the next one in line? I go here and just see. Yeah, this we have. And now it's the timestamp related things. So if config is set for the timestamp or the SHA, the hash, then when we create, wow, time zone computation here. Oh, that's going to be fun. But chrono is here, so I think that takes care of that. Whew, so a lot happens here, huh? I'm looking for these actually, the add entries. So it's SHA or short SHA. And before that, okay, so it's different ones. Huh? Look at that. So it's different keys. So it's about the commit, I guess, that is shared, is it? So here's the time zone related things, add config entries. And here's the SHA related things. Okay. And all we need for this to work is to peel the head, or to get a commit ID, or actually an object ID. Oh no, it wants to have a commit. This peels to commit, that's fair. And use that SHA in some way. So I guess you can skip right to this one, which looks simpler than doing the time computation. And the short SHA here, that's also going to be interesting. So let's go for the normal SHA first. So it's essentially this, I guess. If config SHA, and then we go with the normal and the short one. And both. You can do both. Really? How's that? Ah, right. You just set both variables. Okay. So that's interesting here. So this enumeration here really wants to be some sort of thing that isn't mutually exclusive, because we have normal, we have short, and now we have both normal and short. And there's a lot of code duplication here. Maybe we can also work on that to avoid this. All right. But copy paste is how we can get started, I guess. By the way, if you have any suggestions or on how to approach this, I'm all ear. But this way, with the copy pasting here at least.
Yeah, you have the basic structure, and then you can kind of work from there.
Yeah, I think I missed something. How's this? Oops. How's this top level? Check. Git config char. Okay. Interesting that this is Boolean. Interesting. So let's hide this for now. Okay. Short char. And both. Yeah, this can be removed completely, because there should be a way to sort this out.
To reused.
To be reused, yeah. I have the feeling that it's more like an array kind of thing. So we resolve both. We resolve both into normal and short, and then iterate. So SHA kinds or something. Let's do this first, maybe. So I don't know. Maybe that's not rustic enough, but what comes to mind is something like this. Git config char kind. Ah, char, that's the boolean, and char kind, that's the thing that interests us. So probably, yeah. I don't know why this has to be dereferenced here. It's, yeah, let's see. So if char kind matches, great. Char kind, both, then we go for rec and then just put both in. Otherwise, unwrap or else rec. Then which one do we have there? Char kind. So something like that maybe. And then we can iterate over both. Okay. Like that. And now the both is unreachable. Yeah. Okay. So now the code duplication has been removed. If this compiles. Which probably it doesn't, because also the linter is very aggressive. So that should be dereferenced. Let's hope this is copy. It is copy. Whoa. 13 failed. Ah, yeah, right. It runs into this, and now we run into these to-dos. So instead, we could probably also just not do anything. And we're green again. And all we really have is to see this, right? Okay. So now for the commit. For both of these, we need a commit, and probably that's not going to change while we are here. So do we have the head here? We do. Let's see how that works. Head dot peel, peeled. So we can peel ourselves. And there's a bunch of options here, so that's interesting. Let's see what the intuition is and what they do, what the difference is.
I remember you explained this once, where the ref could essentially point, like it could have multiple layers essentially of IDs, right? So you want to always kind of get to the base of it. So you want the fully peeled. But if you know it's only one layer, I guess you would use the first one. The second option, I actually don't know what it does.
Yeah. I mean, I also have to look at it and think, really, is this all necessary, or is there some leftovers that you should remove? Because it's not very obvious, but I do remember now. I mean, the option gives away a lot, because option means, I mean, if this is an unborn branch, or if this is a newly initialized repository, then there is no commit ever. There can't be. So that's this part here. So these two, they would inform me about the lack of an object ID, because there is no object in the whole repository. The branch has not been born. No commit present. And peeled is kind of it's literally the short and quick version for it, like if you don't care. Because this bakes the option into a result. So you can just question mark out of it. And if this works, then you get something that allows you to obtain the object ID or something. So, but it returns a head. So I wonder, how you then get that fully peeled self. So let's assume, like I don't know what we want here. I think if there is nothing, if there is no commit, then we shouldn't, and we can't fill that in. But we have
skip, yeah.
But I also thought that would be the case here. But here they write detached head, so maybe we figure out what they do then and do the same thing, because just skipping it might not be what's actually happening. Okay. So commit, ref head. That's interesting. Ah, look, peel to commit. So that can't fail. And that's a head. And we know that peeling to commit can fail because that head might be pointing to a symbolic reference that does not exist. And this can fail. So this means for us, we do the same. If it's an unborn repository, that fails. And that's cool, you know. I think here it's not entirely obvious that this happens. I mean, sure, there's a question mark, but it's not obvious to you that this case of unborn repositories folded into this. Whereas here you always have to think about it if you deal with the head, whether for better or worse. Okay, but this means I should go with peel, because then in theory it does everything for me. And what's a bit annoying here is nice, peel to ID in place, transpose. And that puts it into a result option. And then just ignores the object ID that it had before, throws it away, and returns itself instead. Which brings me to my next question, like how do I now get this ID easily? Because the whole point of this exercise is that now there is no other way but for there to be an ID, because I'm past this. There must be an ID now.
You just, I don't know, is it an attribute that you can just
Oh, you know what?
Retrieve?
I'm wrong. I'm actually wrong. There must not be an ID now. I mean, transpose. Okay. Transpose just turns an option result into a result option. And this could still be a none in there. We just ignore it. We ignore the return value. We ignore that option. And this means we still have to check what happens here. I think this is just a more convenient way to write this so that you can chain multiple calls. So in this case, I mean, cool, now we can chain it, but do we really want to? We can also peel in place or do an into fully peeled ID. I think that's more like what we want. But the problem with that is then that we don't easily peel to a commit. Or do we? Because this one explicitly says peel to commit. And think about it, what can happen? The ref can point, I know this sounds incredibly complicated when I say it, and it's so much to think about, which kind of, I don't know, am I overcomplicating things? But I'm just a messenger, I guess. The ref points to an object, and this is what we see here. And this object can be what? Like, what can it point to?
It could point to, I don't know, like a tree, I'm guessing, right?
Tree, yeah. And wait, the tree, can we ever peel that to a commit? Can we get a commit from a tree somehow?
I think so, right?
No. The tree does not know commits. commits know a tree, but not the other way around. So once we have a tree, that's it. You don't ever get to a commit. So if somebody creates a ref for some reason that points to a tree, which you can do, then this would fail, right? And we have to make sure that we try to get a commit in some way. That's all I'm trying to get at. So tree can't do anything, fail. What's the other three that we can see?
I'm not actually sure.
A blob. A blob is just a file. And same thing there. We can't make a commit out of a file. So just two objects that are left that are interesting for this kind of peeling, which is a commit itself. We don't have to peel that. It's already there. So only one object that is actually doing anything with the peeling. It's fun that this kind of this complication, this kind of peeling thing, it's really only there for tags.
Okay.
And not any kind of tag.
Yeah.
I mean, wait, maybe I'm just saying something wrong. Not any kind of tag. I mean, there are two kinds of tags, right? There are tags that are just references, and they're tag objects. And tag objects, they are themselves pointing at an object, which can be anything again. It can be another tag, or a tree, or a blob, or a commit. And peeling means follow that chain until you meet a commit. And that chain can be other refs. So you can point to a tag that is just the ref. Or you can point to a tag that is a ref that then points. I mean, every tag actually is. I don't know, actually. I don't know if these objects you point to are sometimes also ref tags, or if they're always tag objects. I don't know, but theoretically both work. And you just have to follow the chain until you meet a commit. So it's tag.
I mean, then the fully peeled ID is still the right one to use, isn't it? Because we either end up with a commit, or what else is there? Yeah, if not, then it's, yeah.
Yeah, it's a great point, because what am I trying to say? It's exactly this. Does fully peeled peel to ID, does this mean we get the right object or not? And how can we assure that this is the right object? So let's see. Into fully peeled ID gives us an option result. And I guess we have to bail out here, like anyhow, I think, huh? So this creates an error. Yeah. Cannot work on a repo without commits.
Yeah, this would be the unborn case, essentially.
Yes. That's the unborn case. And now I just wanted to form it here. And now we have the other error, like the peeling didn't work, and now we have an object ID. And now we can maybe what can I do with this? We can see the kind. That's nice. Ah, yeah, right. That's an object ID. That's an attached object ID. So I can get the object. No, wait. But that's not what I'm interested in. I'm just interested in the SHA, right? So I have to check the kind. Here's the kind. So this OID, it's literally just where am I? It's a git hash. No. That's not the right one. sorry for the confusion. I just think I know what kind of type comes out of here, and it's an easy OID. So this one should be easy to use. However, it doesn't give us the type. It's just a wrapped object ID. So we don't know yet what it actually is. We don't know if it's a commit or a tree or whatever. And that's a problem. It's a problem because while it was peeling, it already had to walk tags potentially and to walk to objects. And in order to know if it can walk more, it has to load the objects. Because otherwise it's just an ID, right? And the type of the object is represented after, or is only known after you've loaded the object. So now we basically have to load the object again, even though it was loaded before for sure. And we just don't have that information anymore. And yeah, I guess that's just something to live with here. Nothing you can do.
Yeah.
The actual peeling, where does that happen? Into fully peeled ID. If it's unborn and detached, there's nothing to do. Otherwise, if it's symbolic, then it uses that symbolic reference and peels that in place. And here is where all the magic happens. But you see it does look up objects here. But it won't tell you about the last seen type. Let's see. So now we are in the ref file store. And phew. This is not super trivial, but it's okay, I guess. I'm a bit confused by... Ah, yeah, okay. It does have access to packed refs, but it's not itself a packed ref. Okay. Now I'm better. So that's a file store. And we can possibly look up things in packed ref as well. And if we are peeled already, I'm just trying to figure out if the kind is there somewhere. So do we degenerate information and just don't provide information that should be there, or don't we? And the thing is, when tags here, look at this, the way we store references. Get packed refs. So this is how you store peeled references. So in order to shorten the amount of time it takes to peel these references, to follow the chain, Git already stores the fully peeled ID like this. So that's the superficial ID, so to say. That's the tag object. And that's the final, that's probably a commit that this thing points to. And just to show what this means, git cat file. So that is a tag object. And it points to this object here, which is of type commit. So here, in fact, it knows the type, but only after we've loaded the object. Whereas the information that we get from the ref database doesn't include the type information. So we don't know what kind of object it is. This also tells us that this API is in fact correct, because in the common case, it does not know the type of object. But if it did have to actually look up objects like it does here somewhere, then you would know the type. And then it doesn't tell you, because here, for example, here it sees, if it's a tag, then get the object ID from there and continue, so to say, and loop until you found something that is not a tag, and then it resolves the object like this. And then you would have the kind, the object kind, but we ignore that. We can't store that here, and that's okay.
So what you get is an object ID. So you then do have to load the object, check its type, and go from there.
That's correct. That's just something I wanted to validate, that what I'm going to write here is true. So now we have a real object, and now we should be able to turn that into a commit, or try to turn that into a commit, because if we can't, we want to bail out, right? We want a real commit. So this beauty here is what you would write in GitOxide today in order to do peer to commit. And maybe that's something we want to refactor. This is something you probably want.
Definitely.
Yeah.
It takes a lot of complexity away. I mean, it's you do have to understand it, and I guess, but yeah, just going through that whole chain, if you have to write that yourself, is it's probably a bit much.
Yeah, I think so too. So now we have a commit object here, a real commit object, and with that we can relatively easily get the SHA. Unfortunately, we do have to resolve it, but it's okay. It's just one object lookup. It's not going to kill us performance-wise. It's just like, could this be more efficient? In this particular special case, yes, because we might know the type, but sometimes we don't. So it's an optimization not worth making. Probably better to find a nice API for this. But yeah, let's get to that. Okay, now CommitID. So my kind of object doesn't have that. Commit, not a function, just a field that is open. You can do toString. You can also do toHex, which is for display. And let's just try toString, because I think toString is implemented as toHex. So that should do the same thing. Okay. std error is not implemented for Git repository easy object. What? So this is a result, and this is also a result. So it seems like I have an easy object somewhere. Oops. It seems like I have an easy object right here. And I try to question mark out of that somehow. And I am a bit surprised. And there's lots of issues with thread sharing. And I mean, sure, I think there's something wrong here with the signature of what we think it is and what it... Oh, no, I'm wrong. Damn. Confusion. It confused me properly. Because look what this does. Trying to commit, it doesn't return an actual error. It just returns the object itself. So we are in an implementation for object, and if it can't convert itself into a commit, it returns itself, which is a way of not consuming itself, because this is consuming. And if you want to try again with a tree, maybe, then you can do that, because you can just take the error case and try again. This is a technique that is actually used in a bunch of APIs in the Rust standard library. This is why I have it here. But I must also say that it's kind of like...
It's surprising, I guess, right? Because you wouldn't expect that from a result to kind of reuse it.
Yeah. I mean, some APIs do it in the standard library, so it's not unheard of. It's more like here for us, it's surprising because we don't want to try with another object type. We want this. This is why we do that. And if it's not the case, then it's okay to bail out and forget about this object. So I think this should really be a real error.
But is there a different function that's just into commit? Maybe that's
yes.
yeah.
But this one panics. Yeah. That's the panicking. That's the panicking form of the below. So if you're really sure that it's a commit, which sometimes you are, then you can do that. But in our case, we're not. So we want this, but we want this to be a real error. Trying to tree the same thing. So I think really this is to be taken serious. This means this should be a real error. So we should be able to do that. Then it doesn't look too terrible because, okay, let's be fair. Let's not fix this right now. Also because time, 36 minutes already in. Let's just say it's okay. And we can upgrade this to a real error. And we can make it an anyhow error and say ref didn't point to a commit, which probably is not too bad as an error message, because whatever, if you were to put an error here, it could just say wanted a commit but found a tree or something like that. But it doesn't have any kind of contextual information like this one has right now, kind of naturally. But something I really didn't like is this initial blurb of errors that are because you try to question mark it, and everybody will try to question mark that, I guess. So like we did, and the confusion I also won't forget. I was really confused about this. Like, why is it an object? It shouldn't be. It should be an error. Okay. And now we have a commit. And it works. Wow. So that was easy, wasn't it? As much as I like this chaining and as much as I like to think about it, this is exactly the kind of things that trip people up, because everybody needs the starting point. Give me the head, do something with the head, give me a commit from the head, and that's the entry point into the graph, and that's where they start usually. Same with branches. So whatever we do here, you have to be careful. Probably shouldn't just be for heads, but also should be for standard refs, because you can just define the ref by name and then you have the same problem. So let's make a commit because it works and see if there's a quick win, because I think I implemented something like this already, but not for head, but it's available for refs. So I could do into referent, and then, interesting. So that can panic. That's a bit mean, but try, it doesn't have try into reference apparently. So that would be nice, or I don't see it here. Yeah, so try into referent, but in theory then you can, I thought you can peel to a particular object type, you know, but no, you can't. Peel, target. I thought I implemented this. Okay, I have to look into this off camera, I think, so that I don't, or we don't end up re-implementing something that already exists. But I thought there was something that tells you, here, peel this to this object type. Peel this to a tree, peel this to a commit, but not here. Okay, never mind then. Then I guess it has to stay this for now. And that is the competition for peel to commit, yeah? Okay, we can do this. This can work.
Cool, yeah. I guess the question is how many layers you want to put in there, right? I mean, if you want to keep the trying to commit convention, you could just abstract everything like this into one function, right? And be done with it.
Yes.
But the question is, how many people are going to use the layer below, working with objects directly, and they will run into this as well.
Yeah, it's a great point. I mean, generally, I think this can stay. Maybe this can be simplified. Maybe there can be less of these kind of peeling functions. This, of course, there's something to figure out, and eventually maybe simplify that way. Two methods instead of three. But I like that you're able to do this, because sometimes you want to have custom errors that are actually specific to you, to your application, and to the way you do things. And this kind of forces you to do it and to think about it. And for some apps, probably mine, I would likely be doing that just to have the good error messages. And so I think that's an asset somehow, except for this. This wants to be changed, but everything else I would consider an asset. But there's other kinds of people who really just want to write tools real quick, and they don't need that. And this is, I guess, why you would consider having some API that is more like into fully peeled commit or something. Or even peel into and then maybe an object type. But then you have to do more. You have to import a type. So most people want to commit. I mean, let's face it. Peel to commit. So I would probably just do the same, really, because this is just this is what you want.
This would also be easy to find, right? I mean, if you kind of look for commit,
yes,
it's the easiest way.
Yeah, and you need it. It's just like it's specialty applications to peel to a tree or peel to a tag. You can, and if you do, then you use this, because then you have to deal with the object itself. But then you don't peel to, and that's also a thing. Then you peel to the end of the chain. You don't see the intermediate objects that might be there. And I actually thought about this, so you can peel step by step, and then you see each thing that comes. But yeah, honestly, I don't know if it's a good idea to do that. But here, I think it's clear that you want peel to commit. Interesting. APIs are hard, but it's fun to talk about it, especially when you have an example like this and references. I'm a bit surprised that this now prints twice, but it's probably because...
Yeah, we tried finding it last time. I wasn't really not sure where that comes from.
Yeah. Does it have... It both is duplicated here, so I don't know. It's probably okay, because we don't do anything twice except for where we have to. Okay. So that's that. I think that's a nice closure here. So next time there can be parsing short references and maybe refactoring this, something like that. And doing short refs is easy and it's hard. And why that is, I think that can be left as a cliffhanger. It's definitely a fun topic to talk about.
Yeah, actually, curious. I thought it would be easier. I mean, that it kind of derives from the idea, from the SHA. But yeah, let's see.
And that's true. That's true. And the short SHA, it could be everything, I guess. Could be two hex characters, and it might still be unique and non-ambiguous. But I think the minimum that Git uses, it's 7 characters. 7. Like, that's not, that's a half byte right there, the 7th hex. So yeah, you have to deal with that somehow. And you have to deal with uniqueness or ambiguity. And if 7 is not good, then you have to go to 8 or 9 or 10 or whatever you need. And that's where the tricky part happens. Like, check for ambiguity and then make it non-ambiguous before you return it. And that requires a whole different way of looking up objects by ID or resolving short IDs to long IDs to validate this. And GitOxide can't do that yet. and it needs to learn that, that's for sure. It has to. And
cool.
this even goes to affecting the object database and how the object database works, because you do need to check every pack that is there and go through every index, every object you have to check, because there might be some duplicates in another pack, and you also have to check the loose objects that might be on disk, and yeah, use the file system to then find the files, blah blah blah, and it's fun. So basically, at least three things you have to deal with, or 4 adjustments in different portions that you have to make. So that's not going to be one session. That's going to be more if you want to implement that with the ambiguity. It's usually okay to go with 7 by default. And as long as we have an API, I think we are moving to the next session already, but as long as you have an API that allows you to check ambiguity that we use initially, we can skip the check and just say 7, and that's fine and probably okay, but then it must be implemented at some point, otherwise
yeah,
it's too unsafe to
it's
use.
not good enough.
Not good enough, no. That's often the case with Git, whatever you think is right is usually not good enough, because there's a ton of edge cases that you have to consider, and that's why Git is actually really, 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 really good. We don't appreciate it, but if you have ever used another revision control system, you had like a ton of other things to dislike, and now all of these are cleared out and fixed, and now we find new things to dislike, and we focus on Git's command line interface and it being too difficult and cluttered. But this also means that everything else works really, really well, and we can be thankful for that, because that's already
100%.
a big portion of what we do. And finding the UI, so to say, a bit ugly, I think that's the luxury kind of level of complaints that we do, even though it's one worth fixing. That said, let's fix some more next session. Thanks, everybody. Thank you.
Next episode. Thank you very much.
Thank you, and bye-bye.